Welcome to Spring LIB.
All right, we've got to draw the skeletal structure for some molecules. Let's just dive right in, shall we? The first one is 3-ethyl 4,5-dimethyl hexane. Well, hexane tells me that we've got a chain of 6 carbons long. 1, 2, 3, 4, 5, 6. Now I can start looking at the substituents at the front of the name. So 3-ethyl. So let's say 1, 2, 3. We'll finish 4, 5, 6. Okay, at carbon 3, I've got an ethyl coming off. That's a 2-carbon chain. So 1, 2. At carbon 4 and carbon 5, I have a methyl. That's what's meant by 4,5-dimethyl. So 1 at 4 and 1 at 5. And that is 3-ethyl 4,5-dimethylhexane. Let's continue. The next one ends with nonane. So that's going to be a 9-carbon chain. Nonane is 9 carbons. So 2, 3, 4, 5, 6, 7, 8, 9. And then we can just start going through. We'll start numbering it from the left. So this will be carbon 1. This will be carbon 9. I'm not going to number all of them, otherwise it'll get really messy. But carbon 2, well, the first thing we have is 2,3-dibromo. So that means we've got a bromine at carbon 2, bromine, and bromine at carbon 3, bromine. Next, we've got 4-chloro, so that means we've got a chlorine on carbon 4. And then 5-isopropyl, so carbon 5, and isopropyl is a branching carbon chain of 3 carbons, just like that. And then 4-propyl. So go back to 1, 2, 3, 4. So chlorine, 4 doesn't just have a chlorine, it also has a propyl. Propyl without iso in front is just a 3-carbon chain. So 1, 2, 3. There we go. Pentylcyclopropane is the next one. So propane, well, it ends in cyclopropane, right? So propane, that's a 3-carbon chain. So we can draw a cyclic version of propane. So we need a 3-carbon cyclic molecule. 1, 2, 3. Now the pentyl tells us that there's a 5-carbon chain coming off of the cyclopropane. So this is going to be 1, 2, 3, 4, 5. So that's a pentyl coming off of cyclopropane, pentylcyclopropane. Next we've got heptyne. Heptyne. So that's going to be a 7-carbon chain. 1, 2, 3, 4, 5, 6, 7. All right. It says at carbon 4, we have a fluoro. 1, 2, 3, 4. Fluoro, that's an F. 2, we have a sec-butyl. Now, sec-butyl is a 4-carbon chain, but it's branching. So at carbon 2, we have the sec-butyl group. So this is carbon 2. So it's drawn like this. That's carbon 1, carbon 2, carbon 3, carbon 4. That's a sec-butyl. On its own, it would look like this. 1, 2, 3, 4, and then that's a sec-butyl. All right. 4 fluoro, 2 sec-butyl, 3 heptyne. 4 fluoro, 2 sec-butyl, 3 heptyne. So here we'll notice that the ine ending instead of heptane, this is heptyne, tells us that we've got a triple bond starting at carbon 3 between carbon 3 and 4. So 1, 2, 3. So this is a triple bond. Now, as we know, triple bonds are linear, so it would probably be best to redraw this molecule such that that linearity is respected in the drawing, if you will. So if this is our 3, 1, 2, 3, that's our triple bond. So this makes this carbon 3. So this is carbon 2, and then carbon 1. This is carbon 4. So we go 5, 6, 7. And then we can replace our substituents that we had before, such as our 2-sec-butyl. So 2, we've got our sec-butyl. But there is an issue here. This is carbon 4. It would be impossible, or at least exceeding the octet rule for this carbon, to have a fluorine here. This is the literal interpretation of 4-fluoro-2-sec-butyl-3-heptine. You could type this name into any structure drawing tool, for example, and this is what you would get out. It's very atypical. This is not a valid name for a molecule, if you will. So there may be an error in this book or this worksheet. You can't have 5 bonds coming from a carbon, but this is quite literally the definition of what that name was. You would also notice that if you were to name this molecule, that it wouldn't be a heptine, because the longest chain, once you place a sec-butyl at carbon 2, is actually 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should technically be a nonane or a nonine. In either case, this is probably the best you can do, but it is still invalid. So you may want to ask about that from whoever made the worksheet or assigned the problem. Okay, let's continue. Next, we've got pentene, 2-pentene. So pent, that's 5, and the 2-ene means that we've got 1, 2, 3, 4, 5, a double bond between the carbons 2 and 3. Let's see what else we've got. We've got 3-iodo, so that means we've got an iodine coming off here. We've got a 4-methyl, so methyl coming off carbon 4. We've got a 2-tert-butyl. So a tert-butyl is another branching carbon chain. This time it is a carbon goes up like that, and then you've got 3 carbons coming off of it. That's a tert-butyl. So that is 3-iodo-4-methyl, 2-tert-butyl, 2-pentene. You may notice that this, again, if you were to rename this after drawing, would actually be 1, 2, 3, 4, 5, 6 carbon chain is the longest chain. So this should be actually a hexene, and the naming scheme would likely be changed for that reason. All right, finally, we've got 2,3,5-triethyltoluene. So toluene, in its most basic form, looks like this. It's a benzene ring with a methyl group sticking off. 2,3,5-triethyl means that we've got an ethyl group on carbon 2, 1, 2, an ethyl group on carbon 3, 1, 2, and an ethyl group on carbon 5, 1, 2, and that is 2,3,5-triethyltoluene.